Welcome to the GOTO podcast. Each episode covers the brightest and boldest ideas from the world's leading experts in software development. Tune in for practical lessons, compelling theories, and plenty of inspiration. GOTO gathers the brightest minds in the software community to help developers tackle projects today, plan for tomorrow, and create a better future. Stay up to date with the latest in tech through GOTO's top-rated events held online and in person in cities like Amsterdam, London, Copenhagen, and Chicago, and by subscribing to the GOTO Conference's YouTube channel, where you can find thousands more high-quality dev talks. Learn more at gotopia.tech.
Welcome to another episode of GOTO Unscripted. We are here in the lovely city of Chicago. It's the first time I've been, and the weather's been amazing. And yeah, just GOTO always puts on a great conference, and we get to speak to some of the awesome speakers. So, Holden, welcome to GOTO Chicago. Now, you obviously done a huge amount of work in the open source and data space. Tell us, how does that work? What have you done? And in the world now where data is just massive and exploded, and it's all about generative AI and LLMs and everything, how does it all sort of fit together, or does it?
Yeah, well, I would say it fits together poorly, but a little bit. Okay. It does fit together. Yeah, so I've worked on Apache Spark mostly for the past decade now, which is kind of a trip to think that I've done something for 10 years. And over that time, we've seen Spark develop. It sort of in many ways took over from MapReduce. But then there's also a lot of other tools around like Flink and things like that. And then we've got sort of more recent ML-focused tools like TensorFlow and things like that. And there is this interplay between the AI tools and the data tools. And so you have to have the data to make the models, or even to validate the models to know if they're going to work. And so you have kind of this classic ETL problem. But then we also have this problem of getting the data onto the GPUs or onto the specialized chips for doing the training. And so this is kind of a problem because the bus there is relatively slow. So copying data back and forth a lot of times would be very expensive. And the other thing that we have is so Spark has this sort of approach to resilience or for handling machine failures, where when a computer fails, we just redo the bit of work that was on that computer. But the problem is with training machine learning models, when we're using many different computers, we can't take that approach anymore, right? If we lose one computer in the middle of training an ML model, for the most part, we can't just, recompute the part that was on that machine. We have to sort of recompute a lot more. And so this is introduced in a form of scheduling called gang scheduling into Spark to support those things, and also new techniques, because so a lot of the machine learning tools they're written in Python ostensibly, but in practice they're CUDA libraries or whatever. And so they're largely not in the JVM. And so we have this problem of how we get our data from the JVM onto the GPU or into the place that our machine learning libraries can use it. And so the Arrow project has been sort of increasing importance as sort of the lingua franca between these different tools. So it's sort of the thing that glues everything together in a lot of ways. Okay.
I mean, for people who maybe not familiar with Spark, what is it about Spark that differentiated it from MapReduce? You did talk about the individual retry and the different things, but people who are not familiar for Spark, because there are a lot of different data processing, data handling tools. For people to remember Spark, what should they know about it?
Yeah, so I would say that Spark's strong suit, right, the place where it belongs is when you have too much data to fit on a single computer, probably too much data to fit on two computers. Okay. Increasingly, though, we can fit more data on a single computer, right? And that's great and lovely. But on the flip side, the amount of data that we use is also increasing drastically, right? And so we can handle maybe some of the problems that we used to do on single computers. The kinds of problems that we're being asked to solve have also grown. So sort of how to think of Spark I think of it as it's a conductor. It brings together a bunch of different things, and it helps them work together towards a shared goal.
Okay, so is it a distributed computing platform that you would, even install Spark or have a managed Spark service that runs on a fleet of computers and runs jobs to process things. How does it sort of evolve from the MapReduce part, or is it using this similar concept of mapping things out, doing the calculations and then reducing that to the ultimate result, or is it a different paradigm?
Yeah, so I would say that there are shared parts. So that there's definitely the mapping things out that remains the same, and then we do have what's called the shuffle step. And that's very similar to sort of like the reduce step, but not necessarily exactly the same. And that's where when we need different pieces of data that's on different computers, we shuffle the data around. So all of the data we need to answer something is on the right computer together. A lot of what made Spark successful, in my opinion, is that in MapReduce, you have to spend a lot of time thinking about what is your map, what is your reduce, and you have to sort of manually put a lot of different things together to get good performance. Whereas in Spark, you can write a lot of small individual things, and the optimizer will just go ahead and figure out like, okay, I can put all of these things together into a single pass over the data, and here is where we have to like do this kind of expensive thing. And then once again, I can put together all of these things, and it sort of takes a lot of this abstraction away from you in terms of like having to think about the difference there. The other one, of course, is the resiliency model, which you alluded to. And so that is in MapReduce, we handled machine failures by writing data out many times so that if a computer went away, it was fine. We would just go and read it back in from disk. Whereas in Spark, it was like, well, we could do that. And in fact, actually, if you do have a problem where that is the right solution, there is an option that's called checkpointing. You can use it in Spark. But the default is very much, most things are not too expensive. So if we lose it, we can just recompute it. We can just get this little piece back, and we'll do that. And so that made Spark generally faster than MapReduce in a lot of ways. So
is that because the individual jobs are smaller, and so it's just worth doing the compute thing, or?
So I mean, I would say that even with the individual jobs being the same size, right? It's that, yes, we lose machines, but we don't lose machines all the time. So occasionally recomputing is cheaper than always writing to 3 disks. Because writing to 3 different disks is very slow.
Yeah. Splitting all these jobs out, putting it together, wrangling it all. When you were talking about machine learning and Gen AI across GPUs, the bottleneck before, I presume, was storage writing speed. Things are obviously going to be in memory for speed, but then, network transfer costs to get things between. When you're running things on a single GPU or multiple GPUs on the same box, that networking part is still a bottleneck, but obviously a hell of a lot faster than what we've had before. So is that the sort of evolution of Spark, is to being able to take advantage of that data locality in different ways? Because I'm also understanding that scheduler was, moving data around to put things together so you could compute it together. Because data has that sort of, even in a small part, has a little bit of gravity that you've either got to bring the compute to the data, or you've got to bring the data to the compute.
Yes.
So is that what the scheduler does, is doing things around, and then in a sort of AI chip model, CUDA and NVIDIA is doing that at ridiculous scale?
I mean, in many ways, yes. We do very similar things where it's like, we bring the data to the right place, or we bring the compute to the right place. And these are actually tunable configs that you can do sort of based on because as you mentioned, the network is a lot faster, right? We have just giantly fast pipes between a lot of these machines. And so you can configure how long should it wait for there to be room on a machine to run a task versus just copying the data to another machine that could run the task. And these are sort of tunable options.
Okay. I mean, because obviously with AI at the moment, the chips are super expensive, and wasting any time doing any training or any data analytics on that chip is obviously super wasteful. So is that the sort of evolution of Spark that you're talking about as well, is also making these efficiencies to use the hardware to the best ability?
Yeah, and that's actually something it's new-ish in the current versions of Spark, and in the next version of Spark, I think it'll be very solid. We introduced something called resource profiles. And so resource profiles are sort of a way of saying this part of my job needs these special pieces of hardware. And so this is really important because for a lot of things, you don't need those GPUs, right? There's just like these critical parts where you do need them. And so you can tag those critical parts, and then Spark will only use those resources when it needs them.
Use the best hardware for the job, kind of.
Yeah. And so that's I think something that's super important. And actually, a fair amount of that feature came out of NVIDIA, not surprisingly, right? Although on the other hand, it may be a little bit surprising because it makes it so that you don't have to use them for the whole job. So they maybe don't get quite as much money. But I think in the long run, of course, it is better for them and better for the industry.
Yeah. But what mistakes do people make when they doing Spark or even distributed data and things like that? I mean, it's obviously a massive space. There must be many tripping up points and things like that. If you're advising somebody who's going down this road, what are the kind of things that they should or shouldn't do?
Yeah, so I would say that the most common sort of root cause of problems that I see is not taking a look at your data first. As it's understandable, these data sets are quite large, but a lot of problems come from misunderstanding cardinality of certain kinds of data. And then because you don't understand sort of the cardinality of your data, you ask the computers to do things that it's not reasonable to do. And they'll do their best, but it'll be incredibly slow or expensive. Whereas if you did know, you might have asked it to do something else instead. And so it's kind of a generic piece of advice, right?
So is that like a data preparation step? Is that better categorization, understanding, sanitizing data? The better your data is structured, the better insights you're going to ultimately get out of it, or?
Kind of. Okay. In a way, I would say that, yes, data sanitization definitely plays an important part.
But it's not everything.
But I would say also, in addition to once you've sanitized your data, I think it's good to look at the distribution of the core properties that you're analyzing, right? Do you have a distribution a very nice normal? Do you have a skewed distribution? What does this look like, right? Because you use very different techniques for working with these different kinds of data. And for example, if we have data with a really massive skew, which is very common, you need to do things differently. And in fact, I would say that it is not uncommon for me to find that people strongly believe their data is not skewed. But when we go and we look at it, it's no, your data is skewed. And in fact, everything is moved to one computer, and it's very sad. And we have these other 100 computers, and they're doing nothing. So let us think about how we could structure this differently.
So I mean, it's a classic parallelization problem of deciding where your stuff's going to run and proper distribution. Yeah. Where's Spark going in the future? You also mentioned some other open source projects. Spark doesn't exist in a vacuum. You were talking about, a bunch of other kind of things. Is Spark alive in 10 years' time? Well, what would you look back on and say that Spark had achieved or had, helped the world?
Oof.
Or maybe it's too far out, but either way.
I mean, is Spark alive in 10 years? Probably. Realistically, it might not be as important in 10 years. I think that's quite likely. I think it's very likely that we'll see some other tools come and disrupt the space, as we say. One of them is Ray, which certainly has some very interesting properties. I think it's quite a fascinating tool. But on the flip side, Spark is now used for so many things. It's not COBOL, but it's going to be difficult to get rid of, right? Even if we have a magic wand and things are better, right? There's still MapReduce jobs out there.
Yeah.
Right. And
so, I mean, what use cases is Spark very well suited to? Because, I mean, data is a very generic term. And then, what are people picking Spark to use, and it's the wrong tool for the job, rather? Yeah.
So I would say that sometimes I see people using Spark for things which, frankly, really they just need local parallelization over, say, a pandas data frame. On the flip side, it's kind of hard to do, so I get it. I think it's, as I was saying earlier, very well suited to data sets which are just too big for a single machine. I think it is also okay for things where, it does fit on a single machine, but it's very slow, and we want a high level of parallelization to make things go faster. I do see it used for that a fair amount. One of the more common mistakes that I see in sort of just general places is the assumption that Spark will parallelize everything. And this is not true. It will only parallelize the parts that you do with Spark. And so it is important to understand which parts of your program are being done inside of Spark and which parts of your program are not Spark. So like once you call 2 pandas, it's not in Spark anymore, and it will in fact not go any faster. And if truly this is at the point where like you filtered your data down enough, it might even be time to stop Spark. And then you can go ahead and you can call spark.stop, and you can just do the rest of your work in pandas. And this will be great. You'll save a bunch of money. And it's fantastic.
Okay. And we talked about large language models and AI and all this kind of thing. Obviously lots of data, lots of data processing and everything. Not necessarily even about Spark, but I mean, what are your thoughts on the sort of, AI revolution we're going through at the moment, and, how data plays into that?
Yeah, I think data is very important for large language models. I think my talk here at GOTO Chicago is very much around how do we use the data from independent medical review boards to try and build language models to help people with insurance problems in America, which is a depressingly common statistic.
Yeah, so your talk, just to summarize your talk is about using Gen AI to people who've been denied insurance as a sort of remedial mechanism to be able to understand the process or help them through finding out why that happened. Is that correct? Or?
So more when they've had a claim denied. So
a
they
claim
haven't
denied,
been denied insurance because that's
not insurance denied, but a claim denied. Yes.
Yeah. But yes, that's fundamentally what the talk was about. Yeah.
And what was the genesis of that, and data wrangling with Spark over many years, and then sort of pivot to talk about machine learning and Gen AI in terms of insurance is a different thing.
Yeah, I will admit it is a little bit different. I haven't worked for an insurance company, and it's maybe not the normal space for someone to start thinking about. There's a few different things that sort of brought it on. One is like I got hit by a car, and so I had a lot of insurance bills. No one agreed about who should pay for things. The classic American story. Also being trans and choosing to medically transition, even in California, and working for large, ostensibly progressive companies. Those insurance plans didn't always do what they said they were going to do. In fact, rarely did they do what they said they were going to do. And just knowing a lot of other people. And so I'd say like I started working on it sort of probably as a result of that. But I have ADHD, among one of my many wonderful or terrible qualities, depending on who you ask. So I do many different projects, and they don't always make it to the point of something that's usable. But the thing which pushed me over the edge was the pet insurance company for my dog denied the claim for anesthesia, saying that he should have had the root canal while he was awake. And I'm just like, we don't even do that to like...
That sounds crazy, yeah.
Like, he is a 2-year-old dog. I don't know of a single dog that you could do this to, but certainly not a 2-year-old.
Not a root canal.
Not a root canal. I mean, I guess they might do that on humans with local anesthetic, but even then, like that is a terrible experience, and the person understands what's going on. And unfortunately, our large language models don't yet translate to dog, so we don't have a way to tell them, like, hey, we're doing this because there's something wrong with your tooth. So they just think that they're being hurt, and obviously, understandably, are not okay with that. And so, anyways, I got super pissed off with them, and it was like, okay, well, fuck this. Yeah, it was just, it was a bridge too far, and it was like, okay, it is time to finish this project and get it to a point that people can use it, because, it's just too much.
So, because I often think that, we have concerns in the world about using Gen AI for decision making for even things like insurance, like whether you should be insured and what your cover should be and all those kind of things. But you sort of taking on the second step of, okay, you have insurance, you've paid your premiums, whatever, something has happened and your claim has been denied from then on. So, I mean, what is the AI asking, querying, checking, understanding? Is it, looking through a contract and understanding what is the actual sort of outcome of the process?
Yeah, that's a great question. So at its current iteration, which is what I'll describe, and then I can maybe talk about a few things that I want to do a little bit differently. So mostly it it processes the denial, and it extracts sort of like what was denied, the reason that the insurance company stated for the denial, and that's sort of the starting point. And then we also look at the patient can provide their health history. A very common reason for denial is that insurance companies will say something is not medically necessary. In fact, they say this for all kinds of things, like my physical therapy after getting hit by a car. They're like, you don't need that much physical therapy. I'm like, I literally can't walk right now. So I think I probably need more than 1 hour. I think I expressed it more colorfully. In my defense, I was high as a kite on opiates from broken bones. But yeah, anyway, so it says okay, this is what we understand. Does this look reasonable to you? And you would say yeah, this is right. This is the procedure I was going for. This is why they said it was denied, and provide some of my history. And then we would go ahead and we would take that information and we would generate an appeal that would probably incorporate some of the history, and it would also, because it's based on the historical appeals that have existed, it's more likely to be successful for the ones where there have been previous denials for similar procedures. And for better or worse, there's a lot of those that are reached the Independent Medical Review Board. And this is good, right, to an extent. It's not perfect because it sort of depends on the person providing their medical history. And I spend a lot of time thinking about health insurance, and even I don't know my medical history very well, right?
And whether your insurance company knows, or you've given the same information to them. So
they don't care. The insurance company, the
default's going to be no, because it's going to cost them money. So
yeah, the default is go away. But yeah, and so it's so one of the things that I want to do is switch it. So instead of asking the person for their medical history, we instead ask them a bunch of questions about their medical history, because I think that I believe that if we do that, we'll be able to get more context to feed into the model and produce better appeals. But I haven't done that yet. That's something I need to do. But it's definitely the sort of thing of this is a project that I do in my time after work. So there is only so much that I can do right now.
Yeah. And so are you train your own model based on existing insurance claims and denials and that part, or and obviously that needs an amount of data. That's not the kind of thing you phone somebody up and say, can I have all your insurance claims and denials, please?
It's called the IMR data, or Independent Medical Review data.
Okay.
And it's essentially a third level appeal data set. So you're not going to have everything in it, and you're only going to have things in it that are being appealed for medical necessity. And so there's a bias there, but it's the best data set that I could find. There are tens of thousands of records. And so I do a bunch of things to that data to try and produce the kind of data that I need for doing the fine tuning. It's not perfect, but that's sort of the starting point.
So people will fill in their history, fill in what's happened to them. Obviously, there's an insurance contract and company that you would know about, and ultimately the challenge is sort of matching all these together and using. Looking through the documentation or the plan you have, finding out what is and isn't covered, looking at your medical history, and then trying to infer whether they've been unfair to you or not. Is that the sort of quick summary of doing that? Because you could do it yourself, but it would be volumes of information. I suppose volumes of information just looking at the things you know about, but obviously you're training it on other people's data and other people's existing appeals that have worked. Yeah.
And I would say that there's also sort of this challenge of, and we sort of reference it of like the contract, right? That should exist, but to an extent, I do some very limited processing of the contract. But in my experience, most people do not have their plan contract, and so you kind of go based more on what the regulations require the insurance companies to do, rather than necessarily the terms of the contract. Now, if they have their contract, that's great, and we can feed it into a model. But many people don't have it, and even there's actually a requirement that insurance companies provide it on request within a certain period of time. Not a lawyer, et cetera, but in my experience, insurance companies don't do that, even though they are legally required to in many circumstances.
Well, it's easy for them to obfuscate and just... If they're not, legally they are under obligation, but we know the stalling tactics for medical and insurance altogether, it just doesn't happen.
Right, and there's and the interesting thing is, so a lot of Americans are insured under what's called ERISA, which is, this regulation is, I don't know, well, I do know why it exists, but anyways, it's for privately funded health plans. And in these cases, it's kind of not exactly clear who the plan administrator is. Like, is the plan administrator Anthem Blue Cross, or is it your employer? And the answers that you get when you ask them may vary.
Wow.
And they have legally distinct, and this is really important because on request, the plan administrator must do certain things, but there have been court cases where the person only asked the insurance company, and the insurance company went, whoa, we're not the plan administrator. We're just acting on their behalf. And I'm like, how is an individual supposed to know that the number on the back of their card, anyway, whatever.
In fact, a fundamental question that you can be insured by somebody but not quite sure who they are is also astounding. Yeah,
it is incredibly opaque, obtuse. And then there's also, on top of that, there's things like multi-plan, where, so for example, you could actually have an insurance contract that's written by this other insurance company that uses another insurance company's network, but the ultimate financial responsibility is you don't know. It's so confusing.
So lessons learned in building this, things that went right and wrong, that surprised you, that was easy, that annoyed you because they were difficult. Yeah, what's the sort of lesson in building what seems like an interesting app to solve a particular problem that yourself and many people have?
So I would say that renting GPUs by the hour is expensive, which is annoying.
Is this mainly for the training of the model? Or
for
are you
the
doing
training,
it for inference as well?
And so this is actually one of the decisions that I made was we would rent GPUs for training, but we would use own GPUs for inference because renting them for inference would just be too expensive. But this limits, obviously, the kind of model I can make to a model that'll fit in the kind of GPU I can afford, which is not as large as one might hope. But the one is you can rent GPUs for training and then use smaller ones for inference. Very, very classic thing. The thing when you do that though is the GPUs that you rent are not going to be anywhere near you network-wise, right? And so you have a sort of the classic problem of you have a giant pile of data that you need to get to these machines in the middle of nowhere.
Sounds as though we were talking about earlier of getting your data to the computer the data, a Spark problem,
Right, and the problem is when you're doing this as kind of a individual, right? You don't own a data center, so these machines are just whatever you happen to be able to find. And so in the inverse of what we were talking about, where normally nowadays you have very fast networks, you actually have a very slow network, and the network is an incredible bottleneck. And so you very much want to configure things differently. So that's one thing. The other one that was kind of annoying is that even in supposedly non-preemptible machines, you'll get preempted probably eventually.
What does preempted mean?
Preempted essentially means what you're doing will get stopped and just thrown aside. Often, normally, I'm not accusing anyone of this, it happens because of money. The other
so this is when you're renting a GPU and you sort of run a job on the GPU and they eject your job out for some other job. Okay, yeah.
Now, of course, it can also be ejected out because the hardware failed, right?
Yeah.
And in theory, you can rent GPUs that are non-preemptible, and that means they'll only kick you out if the hardware fails. But
didn't quite work out that way.
I mean, I don't know why, but I'm just saying it's possible that you should plan for perhaps a higher level of preemption than one might normally expect given.
But does that just completely break the job and the job needs to completely start again? Because harking back to earlier when you're talking about restarting things.
This is a fascinating. So checkpointing, right? This is sort of a thing of it's a trade-off of how often you sort of write out the intermediate steps of what you've been doing to a persistent storage, and also, do you have persistent storage available on this computer?
Yeah.
Some places you can, some places you don't. So I think it is very important to get persistent storage and get that attached to your machine so that when you are preempted, you don't have to start over. You can start from one of your checkpoints.
So when you're doing the model training, I'm thinking, the checkpointing is one part, but obviously, the training steps that are happening, that needs to be stored and saved somewhere else. How does that bit work?
Are you talking about the final output?
Well, is it just a final out, or I'm understanding the checkpoint as the place where you are, but surely there's intermediary steps that are involved, or because that's just running in the GPU. Right. It's in, I want to not say memory, but it's in processing.
Yeah. So it's in VRAM.
VRAM, there we go.
Would say, yeah, it's just in VRAM, and so when the computer dies, you lose whatever has happened since your last checkpoint. It's okay. It's not the end of the world.
Is checkpointing then a lot of data that needs to be saved?
Yeah, generally speaking, checkpoints are not small. And really, they also sort of build up over time because you'll do many of them quite likely.
And what were some of the things that surprised you that were easier to do, or that worked really well, or new things as you were doing the project? You did something differently or changed track, and it was like, oh wow, that was a much better solution.
So I would say that one of the biggest things that changed between sort of when I started and where I ended up is there was an introduction of a tool called Oxalotl. I might be mispronouncing it, but it greatly simplified the fine-tuning process, and it made it a lot easier to try different models. So, because with fine-tuning, you might try different base models to sort of see how they perform, and it made it much more reasonable to do. And so if anyone's out there trying to do fine-tuning, I would say check out Oxalotl. I think it's a great tool. It's open source. I have no relation to it besides using it.
Yeah, just quickly, because you mentioned open source, obviously Spark was open source as well. I mean, that's obviously of massive importance in data and machine learning and this kind of thing. What are your thoughts of the state, a bit of a tangent, but the state of sort of open source at the moment? And thoughts on path forwards, because there's been a lot going on in open source over the past few months.
Yeah, I would say that it's definitely been a rough period of time for the open source. And there's just been some quite frankly, I would view it as unacceptable behavior from certain participants in different communities. Is this licenses
changes that you're mentioning or thinking of?
License changes, trademark disputes, different specific instances. And by unacceptable, I don't mean illegal, to be clear. I'm not accusing anyone of breaking the law. I'm just saying that they're acting in ways that are not...
There were assumed contracts or understandings with people and those were maybe broken,
Yes. And so I think it's unfortunate. I think it to me, in some ways, it does show the importance of foundations that are not controlled by the corporate entities of which they're a part of. I think, unfortunately, how do I say this without getting in trouble? Some foundations are perhaps more controlled by corporate entities than one might hope. I think that's unfortunate. To be clear, I don't think that it's a balancing act, right? I think frequently some foundations will also take it perhaps too far in the other direction, where they will refuse any corporate money out of the fear of tainting things. And it's well, yes, it's a very noble goal, but perhaps, maybe we should take some computers from them because...
altruistic but doesn't pay the bills kind of thing. But is that one of the fundamental issues with open source, that, it has also been, put together with the free as open source, and, a lot of people have taken the free to be in terms of free from the money aspect, when it's more the freedom of being able to do what you want with it. But ultimately, we want people want the freedom to be able to use software in the way they want, but there is a monetary angle to it, because it does cost huge amounts of, people's time, money, computers, brain power to work on these open source kind of things. Is there a path forward that you can see, or multiple ones, of how open source becomes sustainable after the current challenges we've been seeing recently?
So, and I think I'm not the person for this fundamentally, right? I'm just an open source developer.
But you are passionate about it. So
I am. I care greatly about this topic. But I think that there are other people who have perhaps more informed views here. And so I think there are paths forward. I think that maybe sort of the classic approach of I'll make this software and then offer it as a service to make money. We're seeing that sort of breaks down when someone else can offer it as a service to make money better than the people that made the software.
Yeah, and in fact, I think that's a sort of thing that some people don't understand, that you sort of have sympathy for the people who have created something and then run it as a hosted service, but then somebody else runs the same software better, and then it's like, well, how does that work?
Yeah, and I think it's a rough thing. And I mean, so obviously, like, I make money when people decide to pay me to write software, right? And normally they decide to pay me to write open source software. To an extent that only makes sense in a world where running it yourself is a feasible option. And so I think some of the licensing changes that we see happening are things that I don't think are good, but I am also biased. At the end of the day, right, like, there's this question of how do we still cooperate while existing inside of capitalism? And I think there was a period of time when we had pretty reasonable cooperation, and we're seeing the financial incentives break down in some places. And I don't have a new financial model for how open source gets funded. There's a lot of people trying a lot of different things, but I don't know what the right answer is.
Yeah, and hopefully the right ideas bubble up, and it's always going to evolve. I mean, that's the thing. You can't hark back to the past or predict the future as well. Yeah, we did a nice open source tangent on funding and that. But back to the tool that you've built. Is it available to use? Can people use it? How? What's the sort of consumption model? Yeah, how does that bit work?
Totally. So
sorry, my questions.
No. It is open source, and so that's one option. But I also realize that the majority of people are probably not going to install a Python package on there.
It's like, I've been denied my insurance. I just need help now.
Yeah. So you can also just go to fighthealthinsurance.com.
Fighthealthinsurance.com, okay.
Yeah, and then it's a hosted service. It's free. And perhaps in the future, as we perhaps have been alluding to, I will figure out a way for us to make some money by offering things on top of it. But I would say the business plan currently is that of the Underpants Gnomes. If anyone's aware what that is.
The Underpants Gnomes sounds amazing.
Step 1, collect underpants. Step 2, ? Step 3, profit. And so we're at step 1, fight health insurance.
Yeah.
Step 2, ? is what's next. And step 3, profit, is almost assured because, what could go wrong? But there's some small details to work out in step 2.
Okay. Well, it sounds like the genesis of a great open source tool where it meets a very obvious and tangible customer need, and then funding is to be worked out in the future when and if it's hopefully successful.
Yes. I mean, it also has, unfortunately, sort of... So one of the things that I think of in open source, right, is the times when it tends to be more successful is when open source projects when the users and developers of open source projects are a very similar set. Unfortunately, or fortunately, everyone gets health insurance denials. Yeah. So the users and developers are almost distinct, right? Like, I use my own tool because I work on it. But otherwise, most people who get a health insurance denial are not going to go through the process and then be like, you know what I would love to do is submit a PR to fix that typo, right? Like, this is probably not going to happen. A few people might. And if you're that kind of person, more power to you. Yeah. But it's that thing where it's like, okay, so how do I keep working on this and still have money for food? Yeah.
Because also this is not it may be open source and people can run it themselves, but you're running in a hosted version that's costing you money.
Right. So running a hosted version or even training the model, those things have real costs in terms of dollars. Not huge because I am cheap and I've done my best to
And you're a frugal, good software architect.
Thank you. I like to think so. But so I've done my best to architect it in such a way that the costs are not through the roof, but they're still not zero. And so, I don't know. We'll see. Maybe I'll figure out how to make it survive for a while. I certainly hope so.
I'm sure it's obviously going to help many people because it is the most frustrating thing in the world to be denied health insurance for something that you're entitled to. Yeah,
it's terrible. It's terrible. If anyone works for a health insurance company, I'd encourage you to look in the mirror, think about your life choices, and if you want to do something else.
Or help. Help.
Yeah.
And
or you can come and help overthrow your bosses. and to be clear, right? When I say look in the mirror and consider your life choices, I have done things in my life that I'm not proud of. We all have to survive in capitalism. I totally get it. Maybe you look in the mirror and you're like, hey, I hate that I have to deny these claims, but I'm going to do the best that I can to try and help the people that I can. But I got to eat. And yeah. America.
That's an awesome spot to end on. Thanks so much for spending your time. I love talking about the open source and talking about Spark and data processing and how that links to machine learning and everything, and your super altruistic, amazing project to help people with health insurance. So yeah, thanks for joining us for GOTO Unscripted here in GOTO Chicago, when we get to speak to these amazing speakers who are doing awesome things in the world of our lovely software engineering practice, I suppose. Thank you very much.
Thanks for listening to this episode of the GOTO podcast. Head over to gotopia.tech to discover lots more content from the brightest minds in software development.